Welcome back, Physical Science 20. So now we'll look at the rules for ray tracing to see how, in fact, we can do this. So using the following strategies for spherical mirrors, refer to figure 1710, we can look at that. But what we'll do is we'll just go through these rules, then we'll come back to them as we draw it. So use lined or graph paper, that works the best. Draw the principal axis of the mirror as a horizontal line from left to right of your paper, leaving 6 blank lines between the 6 blank lines below. Above and below, just so we have enough room above and below to draw that. Place a point and label on the principal axis the object C and CF as follows. If the mirror is concave and the object is beyond C, away from the object, place the mirror on the right side of the page. Place the object on the left side of the page and place C and F to scale. So quite often you can see we go from left to right. The mirror is on the right-hand side. If the mirror is concave and the object is in between C and F, place the mirror on the right side of the page, place C at the center of the paper, and F halfway between, and then draw it to scale. For any other situation, place the mirror in the center of the page, place the object F at the left side, and place it to scale. And we'll see when we draw them how that in fact works. To represent the mirror, just simply use a vertical line. Now, I know all the mirrors are curved in one way or another, but use a vertical line because the geometry will work out better if we in fact do that. That extends the full 12 lines of space. This is the principal plane. Draw the object as an arrow and label its top O1, so for object 1. For concave mirrors, objects inside of C should be higher than the 3 lines high. For all their situations, the object should be about 6 lines high, and we'll get into that too. The scale for the height of the object will be different from the scale along the principal axis. Draw a ray. Now, here's the key thing here, the rays that we should draw. So what we're going to do is we're going to star this. Draw ray 1, the parallel ray. It is parallel to the principal axis and reflects out through F. Okay, so that's the first one we need to look at. Draw ray 2, it's just vice versa. It's a focus ray. So it passes through F and reflects out parallel to the principal axis. And then lastly, the image is located where ray 1 and 2 or their sight lines cross, and label that I1. So for image of object 1, the image is an arrow perpendicular from the principal axis because the bottom of the arrow is on the principal axis because the object arrow is there, as we'll see. So we'll run through this. We'll run through these scenarios and see what happens. We'll keep a summary here of what the image is like. So first of all, with these mirrors, let's make just a vertical line. So make sure your ruler is perpendicular. Take a line on your ruler, make it parallel to the principal axis. We'll just draw a dotted line here. And we'll do that for all of these. Dotted line, and down here, dotted line as well. Okay, so we'll use that. We'll even though we know it's a concave mirror, we're going to pretend the mirror is there. Okay, so the first principle, so this has all been drawn for us. The object is way beyond C, and we can see the F distance is half of the C distance to where the mirror vertex is, or where it hits the mirror. So the first ray we look at, now you can see I didn't make this line paper, it would have been better, but you can kind of maneuver your ruler so that to the best as you can, draw a parallel line. Hit the dotted mirror, indicating that the line is going from the object to here, so as best you can, and that is reflected out through F. So go through the dotted, because angle I equals angle R, and we'll draw it through F. Just like that. So that's the first line. Okay? So the image of the object will be somewhere over here. The second principal ray is vice versa. From the tip of the object, go through that focal point. Okay, so we're going through the focal point, and it's reflected out parallel. So as best you can, orientate your ruler so this distance is equal to this distance. That way it will be parallel. Now where those two rays intersect, that's where the image will be. Image will be, now it's kind of confusing because I'm drawing arrows here, but the image will look like this. So the top of the arrow will be there. The bottom of the arrow is touching the principal axis. So we can see it's inverted and just really tiny right there. Okay, so we see that the image is in between F and C. So in between F and C. Orientation, is it upright like the object? No, it is inverted. And size, yes, no, it is smaller than object. And the image type, it is real. You would be able to pick it up on a screen. If we put a piece of paper there, that image would actually show up on the piece of paper. And we'll see what happens when we have virtual objects with a curved mirrors. Okay, so that is when object is far beyond C, so at infinity. Now we'll look at when it is at C. So we'll do the same thing here as best we can. Draw a parallel line. So in parallel, reflected out through F. Okay, so that's the first line. And of course, we're just looking at the two principal ones. Next one, in through F. Go to the dotted line and out parallel approximately. Now be careful with this. What we should find out here is that it crosses approximately right at C, upside down. And this is kind of a tricky one to draw, but we should see that it's at there. So location, it is at C. So that is common traits of objects that are at C. Orientation, it's inverted. Size, it, believe it or not, is the same size as object. And the image type, it is real as well. If we put a screen there, we would in fact be able to pick it up. Okay, so that is a common trait when the object is at C. We get an image that is also at C, same size, except inverted. Now let's look at if the object is in between C and F. So again, we'll draw the first ray in parallel, out through F. Okay, so we have that. The second ray in through F, hit the dotted line and out parallel. So you may find it easier to put your ruler here, that way you can see, make it parallel, but otherwise try as best you can to make it somewhat parallel. So you can see where the image is located here. It's way out over here. So the bottom of the image is on the principal axis, or sorry, the object is on the principal axis, so the bottom of the image is on the principal axis, and the top is going to be here. Again, we want to make it perpendicular to the principal axis, just like the object is. So it looks something like that. So location, it is beyond C, not to be confused with Beyonce. Orientation, inverted. Size, yeah, it's larger than object. And the image type, it is real. Okay, so that's what happens. So we have it beyond C, at C, in between C and F, and we'll look at that case. And then we'll look at some other cases too. What if it's inside, etc., in a bit here. All right. Okay, I think what I'll do is I'll stop there, and then we'll look at, with that, we'll go into real image defects and concave mirrors. Then look at the last example when it's in between there, and also at F.